Hi everyone! So this is the beginning of the week 2 of Module 1, and so I just want to go over the things that need to be completed for this week. Hopefully you have all gotten through the first week of Module 1 with completing the syllabus quiz, acquiring the textbook, and all of the required software. If this is something that you're struggling with, please get a hold of me as soon as possible because this week we're going to be starting with our first lab assignment, which is going to require you to not only have the book, but all of the software as well. Okay, so if you're on the Module 1 page and you scroll down to week 2, you'll see that there are, everything is set up similar to week 1 with things that need to get done. And so the first thing that you should be doing is watching these lecture videos. The first 2 will be released on Tuesday, September 1st, and the second 2 will be released on Wednesday, September 2nd. Another thing, or the next thing that you can do is complete the readings, which are located in the Module 1 Week 2 section. There are links provided. You also should make sure that you have completed reading Chapter 1 in the course text and watch all the videos that are associated with that chapter. So there will be a discussion to participate in this week. So it'll be discussion 2, Real World Geospatial Applications, which is going to be due Tuesday, September 8th by 11:59 p.m. And again, it is strongly encouraged that you get your submission in by Friday to receive full credit. And this allows other students to have time to be able to read your submission and to be able to respond, because it is a requirement to respond to 2 other students. And so we just want to make sure that we have enough submissions in early on in the week to really create a more robust discussion. And like I said, depending on when you submit your first discussion and then your responses to other students, all of that is being calculated into the final grade for that discussion. We also will be having our first lab assignment, managing geospatial data using ArcGIS. And so the link on the module page will take you to that assignment, which basically will direct you to the tutorial at the end of Chapter 1 in the text. And so all of those have, there will be written instructions within the text for you to follow. And then there's also YouTube videos provided on the Canvas module assignment page. So this is also due on Tuesday, September 8th by 11:59 p.m. So make sure to plan your time accordingly. So because we have our first lab assignment, this means that Open Lab will start this Thursday from 6 to 8 p.m. You can find the Zoom ID on the home page to be able to join the lab. So this is not required, but it is highly encouraged for you to participate if you need help on the lab. It's a good idea to go through the instructions before getting to Open Lab so you can kind of know what's going on a bit. But basically, I'll just be there to help if anybody has questions. If I feel like it's necessary, there will be a lab demo, which I'll probably do since it's the first lab assignment. So hopefully I'll be able to see you there. We also have another quiz this week, and this is also due September 8th by 11:59 p.m., but it won't be open until this Thursday, which is September 3rd at 6 p.m. So the reason why I'm doing that is just to make sure that you guys have time to watch the lecture videos and get the readings in before you're focusing on completing the quiz, which will cover information in the readings and from the lecture videos. Okay, so the last thing that I want to go over before I get into the lecture is that we are going to have our first guest lecture on September 15th, which is going to be via Zoom from 6 p.m. to 7 p.m. Our guest lecturer will be Katrina Nystrom, and she'll be talking about geospatial modeling that she did looking at different lamprey habitats. And so please make sure that you have this scheduled out to be able to participate. If you are not able to participate in this Zoom guest lecture, you will need to get a hold of me as soon as possible to make arrangements to make sure that you can get that information when needed. Okay, geospatial science and managing geospatial data. What the heck is this all about? What is geospatial science? Geospatial science is a multidisciplinary field of research and application using geographic information and technology to answer specific questions as they relate to space and time. There are 5 subfields categorized into primary and secondary geospatial sciences. Primary geospatial sciences produce geospatial data. Secondary geospatial science integrate existing geospatial data to answer specific questions. So the first primary geospatial science that we'll go over is geodesy, which is measuring of the Earth. Geodesy is a branch of applied mathematics. It is the science of measuring and representing the size and shape of the Earth, the exact position of points on Earth, and the study of Earth's gravitational and magnetic fields as they change over time. Geodesy is the foundation, quite literally, upon which all other geospatial science stands. Land surveying is the direct application of geodesy and links mathematical models of Earth to physical reality through precise field measurements. The third primary geospatial science is remote sensing. Remote sensing is the geospatial science related to obtaining data from a distance using devices that detect emitted or reflected electromagnetic energy. Remote sensing applications produce raw geospatial data, usually as images. So for our secondary geospatial sciences, we have cartography. Cartography is the art and techniques of making maps. It encompasses both map-making tools and how these tools may be combined to communicate spatial information. A primary purpose of cartography is to communicate spatial information. This requires identification of the intended audience, information to communicate, area of interest, physical and resource limitations. In short, the whom, what, where, and how we may present our information. A GIS, or Geographic Information System, is a combination of software, hardware, data, and scientific methods used to store, analyze, produce, and display geospatial information. Its primary use is for the direct application of geospatial analysis on geospatial data to make decisions and answer questions. Geospatial data refers to a collection of information containing non-spatial attributes that correspond to a specific location and extent in space and time. We use geography to ask and answer questions. Questions that we can ask are, what is it? Where is it? Why is it there? And why do we care? Some things that we can measure are location, distribution, change over time, and relationships. We can also recognize patterns. First of all, is there a pattern or is it random? Is there an area that is more dense with objects than others? Do lines connect meaningfully? Is there a relationship between objects? We could also define patterns. Are there clusters of objects? Are the lines leading to, from, or other features? Are there transitions of color and texture? Are there things near particular areas? We can also correlate patterns. Do certain features correspond to certain other features? Do features behave in a certain way? Does the pattern explain why? So here we can see 4 different maps of the same area, but they all look very different because they're all representing different kinds of information. In the top left corner, we see annual precipitation. On the top right corner, we see Oregon vegetation provinces. On the bottom left, Oregon population, and on the bottom right, Oregon population density. So depending on your intended audience and the data that you're trying to display, your maps could look very different even if you're covering the same areas. So when we're thinking spatially, we can definitely use GIS to tackle today's challenges. So as we can see here, today's challenges require a geographic approach. We can use GIS to analyze climate change, urban growth, sustainable agriculture, water quality and availability, international and national security, energy, epidemiology, disease tracking, natural hazards. In agriculture, we can use GIS to analyze farm management, pest disease and tracking, crop monitoring, yield prediction, soil analysis. For natural resource management, GIS is used all the time in forestry, ecology, water resources, mining, petroleum, fire and wildlands management. For social justice, we can look at different types of environmental injustice, poverty, education, economic access, and racial issues. We also see a lot of maps coming out during election years where we have different cities broken up into the political party zone. So in this map, we can see how this area has been distributed as far as political preferences. So you have your red areas for your Republicans and your blue areas for Democrats. And GIS is a really great way to be able to display that kind of spatial distribution. Another application of GIS is planning and economic development. We can use it for land use and zoning, emergency preparedness, population forecast, market analysis, property tax assessment, and transportation. Furthermore, GIS makes you employable. In fact, the Bureau of Labor Statistics stated employment of geographers is expected to grow 40% from 2010 to 2020, and it continues to grow now. And I think I mentioned this in one of my last videos, but all the skills that you will acquire in this course will give you a good foundation and structure to be able to apply in the work field. If anything, you'll be able to read a map and make a basic map, and those types of skills are highly desirable, whether you're in the natural resources or any other field that requires you making a map. Now that you've seen all the different ways that GIS can be applied, what problems do you want to solve?